Hello and welcome everybody. Thank you for taking the time to join us today for this webinar on the foundations of grid and network modernization. It's an absolute pleasure to be here with you today. My name is Matt Piper and I'm the Global Industry Director for Utilities and AEC. And I'm joined here today by a couple of my Esri colleagues, Patrick Hull, who's an Industry Solutions Specialist at Esri, and Tyler Pilarczyk, a Solution Engineer. Welcome gents, how are you all doing today?
Great, Matt.
Doing well.
Doing well. Thanks. Couldn't help myself with that one. Look, as you can tell, we're pretty excited to be here with you. This is a part of our webinar series for electric and gas, and it's actually proven to be our largest attended webinar for the series. So we've got almost 800 people registered. So we're really keen to get some insights into what you're doing in your network modernization strategies. Just a reminder that this webinar is being recorded, and as long as you've registered, you'll be provided a link at the end via an email, and you'll receive that in about a week or so following this. So it's our objective today to raise your awareness about what's possible from a modern GIS. We're going to share some of our industry experience, as I said, with some of our utility expertise, and Tyler's going to run through some really good demonstrations on some of the capabilities of ArcGIS. Hopefully you can then take some of these lessons learned and apply them back into your industry. How does that sound, Tyler and Pat? Pretty good?
Sounds good.
Good, let's go.
All right, you guys got the hard work. All right, before we get too started though, we're just going to move on to some logistics. On your control panel on your screen, you'll see there's a control box. Now, there's lots of stuff you can do here, but the most important thing for us is in the middle of the screen, there's a section about asking questions. We really care about the questions you're going to ask. So as we roll through this webinar, if you do have questions, feel free to write them down and submit them. Time permitting at the end, we're going to run through these questions and we'll get to as many of those as we can. If we do run out of time, we're just going to reply back to you later via an email. If they're too technical, then we'll also reach back to some of our expertise in-house and we'll get you the answers that you require. So just a reminder, put your questions in, we'll get to them at the end. And just another reminder again that this webinar is being recorded. So the agenda for today, we've got about 45 minutes with you today. We're going to start with what is your grid or network modernization. So we're going to run through some examples about what is building up your strategies. We're then going to look at it from a GIS perspective and about how we enable grid or network modernization in your utilities. Tyler's then going to take us through some really good demonstrations. So the first is going to be on IT and OT convergence. The second will be on spatial analytics and taking all that data, analyzing it, providing insights. And finally, we're going to build out some operational awareness. Now, this is taking all the data, all the insights, and then working how we communicate and collaborate, not just in the control room, but across our boardroom and also to the people in the field. Finally, we're going to wrap this up with some review and some questions and answers. So as I said, we do have about 800 people registered for this poll, for this session today. So we're going to start with a bit of an audience poll. I really think it's important that we get some sort of gauge on the audience and understand how you are positioning yourselves with your grid modernization strategies. So the first question we're going to start with is, in your opinion, what are the things that you feel will assist your utility to achieve their modernization goals? So we've got 5 options to choose. What I'm actually chasing is you just to select your top 3. So is it better modeling capability of the network? Is it deploying modern field operations and solutions? Is it improving resiliency and disaster management? It is improving your overall business intelligence, and that includes things like machine learning or artificial intelligence. Or is it data cleansing and migration tools? So as I said, just select the top 3 things that in your opinion are going to help you drive to your grid modernization goals. We're going to give you another couple of seconds, maybe 10 more seconds to run through. There's no wrong answers, so don't worry. Okay, let's look at some of the results coming through. So we've got 66% better modeling capability in the network. 71% is taking data to the field. 56% is data cleansing and migration. Now, this is actually fairly consistent in what we'd expect to see. The spread of these about your business problems is right across the board. There's no single outlier here that we would identify as the main reason. So when we think about grid modernization, we see that grid modernization actually means a lot of different things to a lot of different people. There's no one right answer or one magic bullet that's going to solve this problem. It can be related to your interoperability. It can be how you implement renewables onto your grid. It's how you engage and communicate with your customers. It's how do we manage all the shifting loads or all the new types of technology that's coming into our grid? And then how do we bring all this different types of data, all these disparate data sets back together and operationalize that back into our control room, so our control room can actually make better decisions on the information they have. We recently released a white paper on grid modernization, and we actually referenced some of the quotes from the Department of Energy. So one of the key quotes that we actually talked through on this was, the grid that we have today does not have the attributes necessary to meet the demands of the 21st century and beyond. And that actually reflected back in that first poll. We had 71% of people say that they're more interested in modeling a closer real life model of their grid. This is exactly the sort of stuff that we're talking about and the challenges that we're seeing in utilities. The Department of Energy also flagged that there were 6 main themes that are relevant to a grid modernization strategy. It is resiliency, reliability, security, affordability, flexibility, and sustainability. Now, I actually think these are really good templates to start building from. But Pat, you worked for 20 years in a utility. Can you just take us through a couple of these? Like, how do these actually relate to a utility, or how do we get these applications into our grid modernization strategy?
Sure, Matt. As I look at this list, the first thing that jumps out at me is that this is a pretty tall order. On one hand, it reflects a lot of the classic utility values. You think of reliability and cost effectiveness. They're the hallmarks of utility work. And we have always addressed those things with GIS, using vulnerability analysis, looking at our existing asset data and finding ways that we can improve our system. I remember doing this at a utility with our line clearance tree trimming program and making some great improvements in terms of reliability. But now we add to that some new ideas, utilizing new technology, integrating renewables, and becoming much more real time in the way that we manage our system. You know, for years we have been rather conservative as an industry, and now we're being challenged to more finely tune what we're doing and to get the most out of our system. That requires more data, it requires more analysis, and it requires more real-time inputs. I like to think of it not really as a destination, Matt, but more of a journey.
Yeah, I think the journey is a good point there. I mean, I look at these things and I think, well, I mean, we're sort of stuck between two positions right now. We are still trying to solve the problems of the traditional network, right? Our grid is old. You know, we have aging assets, we have aging infrastructure. Outages are continuing to grow. We're still struggling with renewable targets. You know, cyber attacks are fairly constant. But our customer expectations on electricity pricing, you know, they don't want to pay any more than they are now, but we need to improve our reliability. We need to improve the way we engage with them. You know, these are really good themes, I think, that we can continue to build on. So thanks, Pat. So I'm actually curious now, like Pat just gave us some good insight, but I'm actually curious to know what our audience thinks of those 6 themes that we just discussed. So our next poll, I'd like to just get an understanding on, of those, we've combined resilience and reliability. Of those DOE topics just covered, what are the priorities in your utility that's going to move your grid or network modernization strategy? So I'm interested to know, is it resilience, reliability? Are you mainly focused on security? Is it affordability? Is it building out your flexibility? Or is it sustainability and how we're going to meet our renewable targets by, say, 2035, 2040, 2050? All right, we've actually got some good results coming straight back in. Very interesting. So we actually see a bit of an outlier here that resilience and reliability is actually really important. So, I mean, we've had some recent wildfires and some fairly significant disasters in California, but across the board, you know, it's how do we actually manage the network, you know, when we're under, you know, those sort of natural, you know, major events, you know, improving reliability for our customers. But then we also have that sustainability as number 2. So this is how do we actually manage and model all these future technologies onto our grid? Some very, very good results there. So thank you for taking the time to do that. I think if we think about this now and we look at this and on an understanding of what our grid actually looks like, this is the traditional grid. So people are very familiar with that. We start with a power plant, it runs through our transmission network, goes through our substations, converts the high voltage to low voltage, through our distribution network, and eventually ends up at our customer. The gas works exactly the same. It's from the pump station to the wellhead, through to the city gate. We have some storage options, but eventually regulated gas network back to our customer. The common node in both of these different tiers is the customer. Now that we transition and we start looking at what the future grid's going to look like, or the modern grid, we start seeing that renewables are actually coming into the grid. This is the solar farms, the wind farms, the utility battery storage systems. So this is actually generating renewables back onto our grid. The customer is actually where most of the change is occurring, right? The customers actually move from a consumer to a prosumer. So the introduction of things like, solar panels on your roof, battery storage systems, electric vehicles, they are all having significant impacts on our grid. And these are actually scaling up and introducing things like microgrids. Right. If we look at it from the gas network as well, the same sort of thing is happening. At the generations component, we're seeing things like biomethane, biogas coming into the grid, generating renewable energies into the grid. This is then running along the regulated network, back up to the customer. And once again, it ends up at the customer, but the customer now has more choice, right? The customer is now informed and they're better engaged, and they are effectively making the decisions about how our grid is operated and how these things are influencing our grid. So, but a grid modernization strategy, I guess, is not just about renewable energies. Like, it's about so much more. Like, we really want an intelligent grid. We want to know what is happening, how it's happening, what time of the day it's happening, how are these things influencing, and how can I make better decisions? So many utilities have already invested in things to make their grid smarter. They've put sensors across the network, there's weather stations, there's all this type of disparate data sets coming back into the control room. But now we're faced with the challenge, what do we do with all this data? Like, we're really trying to understand, I have all this information, it's coming back in, but I need to make smarter decisions. So we move on to our next question. So I'm interested in the next poll. If you try and understand all these different data sets, all these IoT sensors, all the impact to your renewable grids, I'm very curious to understand, what are the challenges that you see that are preventing your utility from moving forward to deliver your network modernization program? So is it your legacy or custom systems integration? Is it the executive support, or just your current business processes are out of date and aren't aligned with a modern strategy? Is it data quality or consistency? Or is it just there's actually a general lack of understanding of what a modern GIS is in your organization? And finally, do you have the capability to access real-time data, and or do you have a modern ADMS? Give it another 10 seconds to come up with this one. Answer as many that apply. Okay, the results are coming in. And once again, we're actually seeing fairly consistently that the results are spread across almost everything. So we're seeing 58% legacy and custom systems integration. Now, that's not uncommon. I think a lot of companies always have the bespoke software that's sitting in there that sometimes is acting as an anchor that's stopping you moving forward. Executive support is something that all utilities need to work for. We need to change our business processes, right? We need to align better with what our modern strategies are going to be. But I think the key one here is that a lack of understanding of what a modern GIS is, and then how do we actually bring all this real-time data and ADMS together? That's where we really need to start looking at how we can actually message and help people understand the capability of a modern GIS. So with that, let's move on and start the conversation about, well, what is a modern GIS, and how do we apply this to our grid or network modernization? So a key component to a successful deployment of your grid modernization strategy is actually building out a geospatial infrastructure. At a global scale, utilities are quickly realizing that location is a very powerful tool. Location provides context and brings data together in a common language of understanding. For utilities, right, this is enabled through a concept of what we've been messaging for quite some time now, of a complete GIS. And the complete GIS consists of three main parts. It's a system of record, which is the authoritative source of truth. One single source of truth that permeates through all your other systems. It's a system of engagement, which is used to share and collaborate. Now, this is both for internal and external stakeholders. And it's a system of insight, which is really about turning all this information into some sort of decision-making through analytics and visualization. So the complete GIS really is the enabler for aligning to a modern utilities missions. And these missions are right across the board of safety, customer experience, best practice asset management, grid modernization or network modernization, what we're talking about today, and of course, innovation. So utilities need to know at all times the details of their network, right? They need to understand the connectivity, what's going on with and around it. ArcGIS and the utility network management extension, right, are the keys to strengthening resiliency, security, and sustainability efforts. So to adapt and meet these needs of the future network, utilities are advancing. Their network is changing and we need to understand it. To do this, we focus on three main areas: unifying IT-OT convergence, spatial analysis, and operational awareness. So to assist me in demonstrating these three capabilities and really show how ArcGIS is enabling grid modernization, I'm pleased to have Tyler Pilarczyk join me. So can you take us through the first demonstration on how a modern GIS is enabling this IT and OT convergence?
Sure, thanks, Matt. So that first thing I want to show is the utility network management extension that Matt just mentioned, which serves as the foundation for Esri's and our partners' GIS utility solutions. Now, a major purpose of the utility network is to be able to model your real world networks, whether that's electric, gas, or water. Now, not only that, but you also have the ability to model these networks at whichever granularity you need. For example, if I zoom into this particular neighborhood and I turn on my associations, I can see we have our blue medium voltage line that's transferring power through this transformer, which is then serving these brown low voltage lines, which of course have customer meters on them. Now, these associations are responsible for establishing the connectivity of our entire network. So if I zoom into my transformer, even if our features aren't touching or overlapping, we can still model how this medium voltage line is going through this transformer, which is on that pole. So what this allows us to do is go to one of our service points and perform a trace from that point all the way back to its original source. So when I run that trace tool, it'll not only track how that goes back to, in this case, the substation, but it will select all of the related features or the connected features along the way. So we can already see that low voltage line that goes through, the medium voltage line, and the poles that are off the line, but are still associated with the low voltage line. Now, if I go all the way to the substation, of course, we can see that that trace has gone all the way back to its original source. Now on our left-hand contents panel, I can then get a breakdown of all the unique features that it's selected along the way. So in this case, we went through 3 fuses, 11 switches, 16 transformers, a couple of reclosers, and so on. So now that we're able to model connectivity in this way, we can begin to integrate with those other enterprise IT and OT systems. In this case, I'm going to go into a different transformer and open its pop-up, which you can see here on the right-hand side. Now you'll notice we're pulling in different information about this particular asset. We can tell which circuit it belongs to, its nominal voltage, and its rated kVA. Now these are attributes that are being managed and maintained within the utility network, but if we go below, we can see that our billing system is telling us how many customers this transformer is serving, and which of those are residential versus commercial. Now right below that, we can also see how many active work orders we have assigned to this particular device. And if we have one, we can see the number and a hyperlink that will launch me into that system, whether that's Workforce for ArcGIS or your enterprise WMS. Now lastly, we're also reading from our IoT sensor network that's telling us the service load of that transformer at this current time. Our pop-up is also then performing a calculation on the fly based off our service load and rated kVA to tell us how close this device is to reaching its full capacity. So now that we're able to pull in from these different data feeds from our different systems, we can start to look at our network differently. So I'm gonna zoom out. I'm gonna bring back our low voltage lines. And I'm gonna take these lines here and then start to symbolize it first by our service load here. And just so we can see these lines pop out, I'm gonna change our base map to a darker gray one. But now we can start to see how load is being transferred across our network based off our IoT service load attribute. Now it's also important to understand which parts of our network are getting close to its maximum design capacity. So this time I'm going to symbolize those lines by the capacity percentage that our pop-up has calculated for us. And once we do that, we can start to make observations like this one where we have that darker orange part of the network that's reaching its close maximum capacity, right next to another part of the network that's actually operating fairly efficiently. Now, if I zoom in a little closer, I can see we have 2 solar panels that have been installed at these customer locations, which we can assume are offsetting a lot of the load that this transformer would originally demand. Now, since we're still continuing to model our connectivity across the entire network, we can take these IoT readings at this low voltage level and summarize those all the way back to the circuit level so we can understand how the entire network is performing at any given time. So by creating this digital representation of our network through the utility network management extension, we can model our network's connectivity, integrate with our other enterprise systems, and discover new insights about our network that we otherwise wouldn't have been able to make. Matt, I'm going to hand it back to you.
Yeah, thanks, Tyler. Might throw it straight back to you, Pat. What you just saw there was a very good demonstration. Like, what do you take away from some of the key things that Tyler just showed?
Sure, well, let me just say at first that as an operations person, I love seeing the work order in there for the equipment right in the operational view. I mean, that's going to save a dispatcher or a troubleshooter a lot of extra work somewhere. But we're used to seeing GIS integrated at some level with traditional IT systems like asset management or even customer information. But as you pointed out earlier, the modern utility really needs much deeper insights about the current state of the network and how it impacts the customers. The value really comes into the control room by bringing more context and deeper information to things like ADMS. And as we're going to see here later, as we bring in other types of data from external sources, even like weather and traffic alerts, when we combine all of those things to see what's happening in an as operated condition on the network, that gives us a much more complete view, and it really sets us up to improve things like operations, our efficiency, and even safety.
Yeah, well put, Pat. I really like the way, Patty started with a conversation about showing the utility network, and even in the poll there, people are really interested in modeling the network as it appears. So being able to start with the GIS to say this is how the network looks, and then being able to map it back to things like your asset management system, bringing in that information. So it could be your make, model, serial number, that sort of stuff. Bringing in then your customer data, and then putting all that information into the control room for better decision making. This has been a challenge that utilities have had for many years, in the fact that we never really brought the GIS and the control room together. They were sat behind different firewalls. The OT data was on one side and the IT data. Using this new platform, we're really now bridging that gap and bringing these usually, two systems that didn't play well together and then sharing it across the organization. This concept of having the real-time state of the network available everywhere really is a powerful notion. Don't you agree?
It is. I think it's probably one of the greatest overlooked capabilities at ArcGIS is the simple ability to bring all of these different kinds of data together. As you pointed out, we've had many forms of this information, but it's usually existed in silos in different parts of the utility. And so when you are operating the network, we have oftentimes historically spawned a follow-up request, but the ability to get that information in real time, provide that to the operator in the field, and to take the best possible action at any point in time is really a major step forward.
Yeah, I agree. I think that's a really good segue if we move on to our next demonstration, Tyler. So the spatial analysis component is really about providing that insight. So having all this data brought together is one thing, right? But what can we do now that we understand? So you've just showed we understand our network better. We understand how not only our circuit is operating, but we understand how each of our transformers are operating due to other influencing factors, whether they've got solar, what's the weather conditions, all these other things. So bringing all that together, what sort of insights now can we develop using ArcGIS to improve our spatial analytics and insights?
Sure, so I want to take that same information and those insights that we started to acquire in the last demo and then start to wrap that into an analysis that we can use to understand how we should incentivize our solar panel installation to improve the operations or the performance of our network. Now, since we're continually reading from our sensor network using those IoT devices, we can start to look at our network historically and understand how those trends vary over time. So right now we're taking a look at the state of the network last Tuesday at 8 a.m. And you can see that our residential areas are, our residential customers starting to get up, but a lot of them are already at work here in our commercial sector, which is where that really dark red circuit is. Now, of course, as time progresses, we can notice changes across our network. You'll even notice that by 10 a.m., we're starting to see these overloaded transformers start to appear on our map. Now, as we get to midday, noon, we start to see kind of either new transformers overloading or the same ones persisting. But by 4 o'clock, we start to see a bit of a shift. Now, by 4 o'clock, kids are coming home from school, parents are coming home from work and turning on the air conditioners. We can start to see those residential areas start to light up. Now by 5 and 6 o'clock, we really reached our peak load. So businesses are starting to close their doors, but still drawing from the network. And of course, people are home and ready to turn on their air on a hot summer's day. And naturally, of course, this is when we're going to see the most overloaded transformers on our network. Now, as the rest of the day goes through, we hit 7, 8, 9 o'clock, we can start to see the network load and these overloaded transformers start to subside. Now, we definitely want to incorporate these kind of insights and trends into our analysis, but we should also consider other factors as well. A good example may be demographic information. So what I'm bringing in now is our tapestry segmentation layer from our Living Atlas that classifies unique neighborhoods based off demographics, which could be income, age, household size, and a variety of spending behaviors. So we can also incorporate demographics, but we might also want to incorporate solar radiation. So if we're going to be prioritizing areas for solar generation, we probably want to look at where we can get the most solar power from. So now that we have our network factors, we have our demographics, and now our solar layer, I've then wrapped our analysis into this configurable model that allows me to define my suitability criteria based off several parameters that the select tools are then going to consider and generate my final output. Now, the way I would actually run this model would be just like any other tool that I run here. On my right-hand panel, I can start to define the parameters which is going to make up my suitability criteria. Now, the first thing I'm asked is our capacity. How do I want to value that in our analysis? Well, in this case, I want to target those parts of the network we saw earlier that are getting close to their maximum capacity. So I'm going to set this at 7. For load, I'm going to rank that as a 3 out of 10. That way, we're not neglecting any residential areas that may not have a extremely high load, but can still benefit from solar generation. For our overload parameter, I'm going to set that as 2. That way, we are considering those transformers that are continuing to overload, but it's not going to be solely dictated or solely focused in those areas. Now, this next part is going to allow me to incorporate some demographics. So in this case, I've provided a range of household income in case there's a specific demographic we want to target, like those likely to purchase electric vehicles. So I can set my average household income range. And then I can also incorporate how much these households are spending on their electric bill and that may be interested in installing solar panels at their homes. And then lastly, I can rank how much I want to value our solar radiation layer, which in this case I'll set as a 2 out of 3. Now, when I launch the model, it's then going to use those parameters and build that or define that criteria I mentioned, and then pinpoint the exact areas across our network that we're going to want to incentivize solar generation. Okay, so we have our results. And just so we can have these lines stick out, I'm going to make it a bit thicker, give it a nice bright color. And now when I zoom in, we can start to see those areas that fit that criteria exactly as we defined it in the model. And we can even see that we have overloaded transformers by some of these, while others may not have overloaded transformers, but also fit the other parameters in our model. And what's valuable about this kind of analysis and running it through a model is that if I need to rerun the analysis based off different parameters, or I want to target a different initiative like AC conservation programs, I can change my parameters accordingly and rerun that same analysis and generate a different set of results. Now, on that note, I actually want to hand this back to Pat, who's going to elaborate a bit more on how we can start to incorporate machine learning to perform a similar type of analysis. Pat?
Thanks, Tyler. First, as I look at that, I think about system planning, and this kind of analysis can really help system planners plan for the network more dynamically. You know, we're being challenged to go from a worst case scenario, peak day kind of a planning to something that's much more real time, and we can definitely use information like that. But while this is going on, while you're planning to target customers to incentivize for solar, customers are out there choosing solar and connecting solar every day. Wouldn't it be great if we knew where the solar would show up next over the next few years? And that would really take our ability to plan up to the next level. I'd like to spend a moment just considering how machine learning can help. Many people have heard about machine learning. There seems to be a lack of clarity in how it can help in these situations. So I'd just like to take a simple example here and walk through it quickly. Machine learning is unique in that it analyzes data and then can help form predictions. And the modern grid really requires better predictions to drive activities like planning and infrastructure investments. Esri's investing in machine learning tools that will really bring power to these kind of predictions. So here in our example, we're going to look at predicting where solar will occur in the future. I have 20 years of historical information about where customers have installed solar. And then I've also got some demographic data like that which you demonstrated, as well as some building information. So I'm going to take this 20 years of information, I'm going to divide it up. I'm going to take the first 15 years, the oldest 15 years, and I'm going to use that to do what they call train the model in machine learning. And this is where the machine learning algorithm will look for and identify the patterns that are occurring and the overlap between those different data sets. Once I've done that, I can use machine learning to predict where I think solar will show up in the next 5 years. And because I've reserved 5 years of data, I can test my predictions against reality, make any adjustments I need to in my model, and then use that as inputs into my planning process. So if I know that solar is going to show up in an area, I may be able to delay capital investment system improvement projects because I know that that load will be offset by solar generation there in the future. As we consider grid modernization, think about the power of prediction for things like load forecasting, energy theft, predictive maintenance, or even failure analysis. You can really see where there's a lot of power in having new data and new data tools to be able to be smarter and more informed about the decisions that we make as utilities. So keep your eye on machine learning.
Hey, Pat, good summary. Tyler, I'm curious. Got me thinking on that one, that we just saw you demonstrate solar and effectively you using analysis based upon demographics and overloaded transformers. What you're doing is really trying to optimize or effectively work out where should we run incentive programs so that we don't have system constraints, right?
Yep, that's correct.
So if we understand where our system constraints are, and we're doing targeted incentive schemes, that effectively ties into what Pat was just talking about, that by understanding where the network constraints are, understanding where the vulnerable areas are, and I'm not just talking at a circuit level or feeder level, you're now talking, we actually understand that this transformer or these number of transformers on that circuit are the ones that are causing the overloaded. By running targeted schemes for incentive programs to those particular households to put solar panels on their roof, that's actually working in our favor as a utility to offset that load and stop us having to do capital expenditure programs, correct?
Exactly, yeah, that's what Pat mentioned too.
Nice. So Pat, on the flip side of that, you're now looking at it from the point of view that by using historical data and the demographics, by understanding buying patterns and those types of residential areas, we're categorizing or understanding those customers better to then forecast based upon what we know where future solar penetration is going to be on our network. So when we're doing planning and forecasting the future, our planning studies are actually more intelligent and more insightful because we know what the future potentially will look like based upon what's happened in the past.
That's right. That's a very good summary. And the beautiful thing about machine learning here is that it adjusts to the data and what is actually happening rather than what we might think will happen based on our recollection of what has happened in the past. Machine learning analyzes the data, and Tyler looked at income levels. Some of the research actually shows that the people that are choosing solar today, are from much lower income categories than we are used to seeing historically. Machine learning will pick that up and feed that right into the prediction. So you're right, we can make the best planning decisions with the best information.
Yeah, I agree with that. We've seen the price of solar and renewable energy is coming down now. That we're at that point of inflection where the uptake is increasing a lot. We have seen this sort of technology used by Esri, to showcase asset management and predictive analytics on failures and that sort of stuff. It's really good to see it now being applied into the sustainability component for the future network and how we're going to handle this stuff where we don't own the assets. It's different when we own the asset. If it's our asset, we understand the failures, we understand the maintenance, we understand all the data coming back in. But these sort of things that influence our grid, it's not ours. So it adds another level of complexity. So solving this sort of future network stuff is really exciting stuff. I do have a curly question for you, but Tyler. So we talked about the solar. So if we're looking at electric vehicles, I mean, you're really talking about using the same analysis to forecast based upon income, based upon previous spending patterns, who's going to, potentially buy an electric vehicle in the future, correct?
Yep. Yeah, that's what we showed. Yep.
All right. So the curly one for you is, what comes first? Is it the electric vehicle or the charging station?
Is it the chicken or the egg, right? No, that's a good point, because I think when we introduced machine learning, it not only improves our analysis, but also how we approach analytics. So like Pat mentioned, the income ranges are actually changing for how people or who's investing in solar generation. So machine learning can help us understand, okay, maybe look within this range, or actually consider these other variables X, Y, Z that you may have never thought to consider. So certainly a lot of exciting opportunities, especially like the one you mentioned, Matt.
But it's all relatable, isn't it? So if you understand who's buying who's forecasted to buy the electric vehicles, we can forecast that ahead and say, well, we can get ahead of that and start planning. Well, the electric vehicle is a 100-mile range, or we like to, So this is where we need to optimize for effectively site selection to install, the electric vehicle stations and stuff like the charging stations. So we really are optimizing the infrastructure to set us up for the future grid.
Exactly.
Excellent. All right. Well, thanks very much. As we move forward now, the next component or the next demonstration we want to run through is, just to recap, we've taken all the IT/OT data. So we've got all these disparate systems coming in from external sources. We've visualized it. We've provided the analytics. We now have a better understanding about what we can do with all this data. But now we're at the point of how do we actually bring it all together, visualize it, and make sense of it very easily. I mean, it's a lot to ingest. It's big data. It's unstructured data. There's a lot of it that seems to be, well, how do I bring it to make any sort of decisions? So Tyler, can you just work through some of the capabilities that ArcGIS has to bring all these different types of data on the future grid together and how we can manage that?
Definitely. So what I wanted to show now is how we can leverage multiple systems and data feeds to, like Matt was alluding to, gaining that awareness about all the different operations across our network. Now, what we're looking at now is a web map that's pulling in different weather feeds, mainly from our Living Atlas that we've used for the demographics in the last demo. The different shaded polygons you see here actually represent weather warnings that were issued by NOAA recently. So if I zoom in, or if I click on that bright purplish pink area, I can see that at 3 a.m. there was a red flag warning that was issued throughout Nevada due to gusty winds and low humidity, which of course has a direct relationship to how likely a wildfires is the start or even spread in certain areas. Now, another layer we've incorporated is regarding our active hurricanes. So we're not quite in hurricane season, or we're not quite seeing any yet by us, but I thought I saw one this morning around here. I'll see if there is one, if not. But in any event, there we go. So we can see not only where the hurricane has progressed historically or in the past, but we can also start to project or see the projection of the hurricane using that cone here around our projected path. So obviously during hurricane season, it's crucial to understand the status and the progress of a hurricane, especially one that can move so quickly. One layer I know for sure that we'll have some content for is our wildfire activity layer. So these are reported wildfires that have been made by, reported by their respective local agencies. So if I zoom into this cluster in California, I can click on a specific icon here. And I can read any information that's been documented for that fire. And a lot of these will also have a perimeter around that fire so we know which areas have been impacted. Now it's also interesting to see this compared with another layer we've had, which is coming from a satellite feed that's constantly analyzing the surface temperature of the Earth and is trying to find and pinpoint those exact or very specific areas that we're noticing a much higher surface temperature than usual and then its surroundings. So those red dots that we're starting to see, these can easily be wildfires that have just started and have yet to be reported by those local agencies. Now the last one I want to bring is actually comes from our partner AccuWeather, who provides a real data stream, a real-time data stream of lightning strikes, which are those black crosses here. So now that we're ingesting or incorporating a bunch of different weather feeds, I think we can start to assess how are these going to impact our assets, our employees, and our customers. So one thing we've done is incorporate a real-time analysis that's done whenever we receive a new lightning strike. And when we do, we'll essentially mark it according to how close it is to one of our substations. So we can see by these thicker red dots that these are lightning strikes that took place within 15 miles of a substation that could either impact it, or since there's already strikes happening in that place, it can eventually impact our substations. Now our weather map is actually a component of a dashboard that we're using to monitor all the activity across our network. So if we look at the main map, you'll notice that circuit map that we've been seeing throughout the presentation symbolized according to the load. We're also pulling in from our AVL feed or our truck locations that we're recording while our staff's out in the field. Right below that, we can start to see our service load over the last 24 hours or so. And another layer that we've added to our dashboard are these fire hazard severity zones. Now these are regions that, due to their physical conditions, are especially vulnerable to wildfires. And of course, they're graded differently, but the highest severity is actually engulfing a large part of our network. So as time progresses and our network is changing and our field staff's moving around, we can start to see the dashboard updates. So once we hit 10 o'clock and we see these overloaded transformers, we get that tally of those transformers, as well as the ones that are within those severity zones. And of course, right above it, we're even tracking our staff that are entering those potentially hazardous zones. And right below that, we can also see the exact devices that are overloading. We can see their asset ID. And right next to that, we can see the specific hazard class that it is currently exhibiting. And if I want to zoom in on one particular one, I just click on it and I can view the transformer here on the map. Now it's also worth mentioning that we're also documenting our max load over the last 24 hours and comparing that with our max solar generation. So again, as we progress through the day and our data is changing, we can see our service load progressing there in our bottom chart. Once we hit our peak hours, we see the spike and we'll notice that our max load has increased from there. So by leveraging a dashboard like this one, we can start to use several different data feeds, whether that's coming from our systems or other vendors. We can start to get a holistic view of our entire network operations and the activity that we're seeing across the network. Now I'm sorry, Matt, I'm gonna hand it back to you.
Yeah, thanks, Tyler. Well, this gets me thinking. I'm going to take some comments from Pat first. Pat, I mean, you worked in the operations space of utility. How important is a dashboard like this when you're actually working in the control center to have this sort of insight?
Well, that's a loaded question. It's incredible. I wish that I would have had this a few years ago. In this part of the country, those wildfire risk zones are really important this time of year, both from a public safety point of view and from regulatory compliance perspective. And as I think about all the different types of data that we saw there, they really give the operations center a view of what's happening. You know, traditionally, the operations center or the dispatcher is reliant to a very great extent on the troubleshooter or the crews to report to them what is happening. With this kind of information, the dispatcher could be the most informed person in the utility and helping direct the work and prioritize the work of the crews that he has in the field. That dashboard provided a real view of the state of the network, even helped visualize current health or risks. And I know executives have been asking for this. And let's face it, today's customers have very high expectations. They're used to asking their phone any question that they can think of. And being able to push this kind of information out not only to our own workforce and our executives, but pushing some of that out to customer service really opens the door to performance that's more in line with the expectations of today's digital consumers.
Yeah, I agree with that. I look at this and I think the same sort of thing. So, I mean, we started with the concept of the hurricane coming through there, Tyler. Being able to forecast where major events are coming in allows you, to prepare, get ready. It's all about that resiliency, about hardening your network. How do you respond better? Well, you can respond better by understanding how your network is going to be impacted. I mean, you show some stuff on the wildfires and then, potential wildfire hotspots that haven't been reported yet. That sort of understanding about, what's happening on my network before it's actually a problem, getting that insight is really, really valuable. And I mean, you showed wildfires, you showed, but hurricanes. I mean, that's the same if it was a flood, if it was anything else. Any of that insight, any of that satellite data, any of those external data sources we can bring in, for that predictive, response time and situation awareness is critical, isn't it?
Yeah, definitely. And I think that real-time information provides a few different opportunities. We can store it and analyze it historically, or we can visualize it in real time, because as we learned, sadly, some of these weather events just occur so rapidly. Like, as we know, wildfires can sadly engulf cities in a matter of hours. So it's crucial to be up to date with that kind of critical information.
Yeah. So, Pat, you got anything else?
Well, some utilities, like Tyler pointed out, some utilities are taking that historical information about where they incurred damage under previous storms, and when there is a forecast for weather, they look to see what happened the last time that they had an event like this, and it really helps sharpen their predictions and stage their crews and materials for the best response to this incoming event.
Well, that's an interesting one. You just talked about version or rolling stuff back. So a key component of this is, I mean, we're talking real-time stuff at the moment. So we're aggregating AMI data, we're rolling it up to the transformer, we're rolling that back up, and we're understanding what's happening at our circuit level. But all this data that we're capturing it's version managed in the utility network, and we can roll back and view what's happened at any point in time. So being able to replay an event after the fact, and learn from those lessons, there's a lot of value that a utility can take from that to say, well, what was my network like at 2 o'clock during that event? Did we make the right decisions? Is there anything we could have done better? That sort of reflection is really, really valuable.
That takes your ability to analyze to a whole new level. And it not only looks backward, but as you pointed out, the utility network can look forward as we place planned projects and we look at various alternatives that we might consider into the future.
Excellent. Well, thank you very much, Tyler, for those 3 demonstrations. I hope you all found them very, very valuable. I mean, I've definitely taken a lot away from those. As we continue through, I just want to recap about what we've just seen. On the end-to-end life cycle here, we look from the generation through to the customer again. For the electric grid, we're really focused on, moving throughout the entire life cycle from generation, transmission, distribution, customer. And if we look at this from the location point of view, a lot of the examples we saw today is how location really is now being deployed as one of the technologies that can provide better insights right across the value chain. So at the transmission level, we're understanding site selection. Where is the best spot that we need to put solar panels or solar farms? How do we offset some of those capital or large expenditure programs? At the transmission layer, we can do better asset management for right-of-way vegetation, that sort of stuff. But it's also understanding, fault locations and, is wildfire incidents or all that sort of emergency response. At the distribution level and into the customer, it's enabling that, field response time. It's being able to operate safely. How do we dispatch a crew safely into those environments if we know that there's lightning in the area, we know that a storm's coming in? It's that intelligent insights. Is there road closures due to traffic works and all that other stuff that we can start bringing in across the network? How do we incentivize our customers, with solar schemes and stuff like that to get more value from the grid? And finally, as we said, it's about bringing all this data together through location into the control room and really lighting up their capabilities so that they've got better insights and can make better decisions. I mean, that location really is, it's not just a point solution or a map now. Location is really the enabling technology across the entire value chain for both electric and gas industries. As a takeaway today, we want to make sure that we leave you with, this webinar, but we also have a lot of content available that you can get access to. So up on the screen at the moment, we have our grid or network modernization poster. This is available on our resources page on our website. This will be provided to you in the link following the webinar. So please jump on, go through. There's some white papers, there's some blogs, there's some downloadable posters, but there's a lot of content in here that you can, get more insights and more, value. We've touched a lot on electric, but these workflows and these use cases are obviously directly applicable to gas. So feel free to go into the gas page and see the strategies and the way that this can actually be messaged and implemented into a gas network as well. If we look at now, how you can stay engaged with our community, as I said, we've already covered our safety management webinar. That was well attended back in April. We're just wrapping up now our grid or network modernization webinar. But in the next 2 weeks, we're actually meeting up at the Esri User Conference. This is Esri's 50th year. So this is going to be our biggest event ever. So if you haven't registered yet, please register. I mean, we've got a large booth set up for the utility section. We're more than happy to spend time with you and work through, your particular issues and showcase some of our capabilities. There's 2 more webinars in this series that will run throughout the year. The next one is on asset management. It's going to be great. This is really going to look at how you optimize your maintenance and asset management programs, managing, enabling a mobile workforce to collect and access information in the field. The last webinar will be on customer experience. So utilities are moving to customer-centric workflow. So we really want to show you how, the Esri platform and ArcGIS can discover and quantify and predict trends and patterns, to improve your customer workflows. And the last thing we'll do this year is we're going to meet up in GeoConnects. This is already shaping up to our biggest event as well. Last year, we broke the records. This year, we plan on doing it again. It is the largest utility GIS conference in the world. It's going to be in Atlanta, October 27th to 30th. Registrations are open, and we're also accepting paper submissions as well. So if you want to get involved and you want to present and share your stories, please, the registration is open. We also have a large social community as well. So jump on a LinkedIn, you can find us there. We have Twitter, and there's a large GeoNet community where you can collaborate and work with other people of similar minds on GIS. So we do have 7 minutes left. So we have run quite well into the time, which is great, but we do have time for a couple of questions. We've been watching them as they're polling through and trying to pick out the ones. So I appreciate the jokes in here. G'day, mate. Enjoying your day. But we've got a couple of questions we might jump through first of all. The first one I think has popped up a couple of times, and it's actually around the utility network. So Tyler, I think this is probably the best one to throw to you. I'm going to put you on the spot. But the question is, do we need the utility network to do our grid modernization strategy?
Yeah, that's certainly a point worth clarifying. So I would definitely stress that the way networks in the future, utility networks in the future, are going to be modeled in a GIS is going to be through the utility network. And that's really because we designed it to be able to support the workflows and the demands people are going to need from their digital networks. But that being said, some of the demos and tools that we use today aren't necessarily dependent on the utility network, like that suitability model that I ran earlier that was using data from the utility network, but that was using other data sets and wasn't necessarily dependent on that network data from the utility network. So I think you can certainly start small and start working, putting together a dashboard, running some analytic tools before you adopt the utility network. But I would certainly, again, stress that the utility network is really going to be that foundation that we're going to have building solutions on top of, as well as our partners as well.
Yeah, really well done. There's actually a question that's popped through just now is whether or not we have any training specific to the utility network and how do we get access to that as well. So I might just take that one. So in the link that we send out, we'll provide you a link to the training options for the utility network, but we do have dedicated utility network training. We do have dedicated ArcGIS Pro training as well. So you know, there's a number of opportunities here that you can get insights. There's lots of e-learning stuff available on how do you use, and videos and tutorials for things like the operational dashboard that we showed today, and that sort of stuff as well. So we will send out some of those links. It's a good point for the training as well. So we'll just take another question. We still have a little bit of time.
Hey Matt, I see a question that keeps kind of reappearing, and it's regards to our gas customers. So what we saw today, can it be applied to the gas industry? Certainly. Now, in our case, we focused on the electric side, but I should definitely mention that the utility network is going to be focused, or is designed so for you to include your electric, your gas, your water, and eventually your telecom networks within that same structure, within that same utility network. So it's definitely supported, and I realize there's a few asks for a bit more gas specific demonstrations, so we'll be sure to incorporate that. But yes, we can certainly tailor these demos and the presentation towards a gas audience.
Yeah, thanks, Tyler. So another one, I think the real-time sort of demonstrations has really got a lot of people thinking. There's been a number of questions pop up about which IoT were you using, where did this data come from, how do we bring IoT? Look, this is something that we've been working on for a while. So there's a number of options you can take here. We can take real-time sensor data. So the utility network is a service-oriented architecture, which is, you know, has the capability to consume all types of data sets. But even if you're running a Pi historian, if you've got this aggregated data back into a SCADA, we can consume that, we can visualize it, and we can take those aggregations. We can then do the analysis in real time as that comes through. So, you know, there's a couple of questions here. Well, what happens with the data? Where is it stored? How do we, you know, manage those sort of information sets? We can do the queries and we can do the analysis on the fly, but we can also just read the data from those sources as needed. So there's a number of different ways we can work with that. So once again, we're happy to take those questions and we'll respond. Rightio, I think we are just about out of time, guys. So there's been a lot of questions coming through, so thank you for the active participation. It's been a great webinar. I hope you've enjoyed the content that we've provided. But with that, I think we'll wrap this up, and thank you very much for your participation.